Theorem 1.3.
Subscribe the channel and press the bell icon to get latest updates from LearnFatafat.com.
Stated as, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Proof. Let the prime factorization of A is equal to P1 into P2 into P3 till Pn, where P1, P2, P3 till Pn are primes. Therefore, A square is equal to P1 square into P2 square into P3 square till Pn square. It is given that P divides A square. Therefore, from fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. We realize that the only prime factors of A square is P1, P2, P3 till Pn. So P is one of P1, P2, P3 till Pn. Now, since A is equal to P1 into P2 into P3 till Pn, that is, P divides A, hence the theorem is proved. Theorem 1.4. Root 2 is irrational. Proof. Let us assume to the contrary that root 2 is rational. So, we can find integers r and s, where s is not equal to 0, such that root 2 is equal to r by s. Now, suppose r and s have a common factor other than 1.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Then we divide by the common factor to get root 2 is equal to a by b, where a and b are co-prime. So b into root 2 is equal to a. Squaring on both sides and rearranging, we get 2 into b square is equal to a square. Therefore, 2 divides a square. Now, by theorem 1.3, we can say that 2 divides a. So, we can write a is equal to 2c for some integer c. Now, we have a is equal to 2c and a square is equal to 2b square. By using this, we get 4c square is equal to 2b square. That is, b square is equal to 2c square. This means that 2 divides b square, and so 2 divides b by theorem 1.3. Therefore, a and b have at least 2 as a common factor. But this contradicts the fact that a and b have no common factors other than 1. This contradiction has arisen because of our incorrect assumption that root 2 is rational. So, we conclude that root 2 is irrational. Let's take an example in which we have to prove 3 root 2 is irrational. Let us assume to the contrary that 3 root 2 is rational.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
That is, we can find coprime A and B, where B is not equal to 0, such that 3 root 2 is equal to A by B. Rearranging, we get root 2 is equal to A by 3B. Since 3, A and B are integers, A by 3B is rational, and so root 2 is rational. But by Theorem 1.4, root 2 is irrational. So we conclude that 3 root 2 is irrational.
Like, share and subscribe LearnFatafat.com and press the bell icon to never miss an updates from LearnFatafat.com.